Hi students, let's look at this question here, which was taken from the year 2020, paper 1, question 11, the actual A-level H2 math paper. This question is on application of differentiation, I believe. So let's see how we can do this proficiently. So in the sports science, studies are made to optimize performance in all aspects of sport, from fitness to technique. Okay, in a game, a player scores 3 points by carrying the ball over the scoring line, which was indicated as XY here. So this is your scoring line here. Then when the player has scored these 3 points, an extra point is scored if the ball is kicked between two fixed vertical poles. If the ball kicked between two fixed vertical poles at C and D. Okay, so in other words, these are the two poles here, C and D. So I'm going to draw the pole here. Alright, so this case here, this is C and D here as well. Okay, so these are the two poles. Okay, two poles. Now, after which we were told that the kick can be taken from anywhere from the line A to B. So I'm just trying to understand this question here, A to B here. So any point here could be, you can take a kick from here. So this is K, labeled as K, right? So it's actually, they were told that the scoring line, the player crossed the scoring line at AB is perpendicular to XY, which is here. Okay, so this is 90 degrees. Great. So the distance C and D is 4. So this is 4 meters. Here's 4 meters, right? And XC is equal. So this one here, this is P, M. So this both here are equal length. So this length here are equal. These two sides here. All right. The kick is taken from K, and K, AK is XCM. The angle CK. This is theta, so this is theta here. Okay, great. So now the next thing is, by expressing theta in the difference of two angles, or otherwise show that tangent theta is, we need to show, so the first part, need to show tangent theta is 4x over x squared plus 4a plus a squared. Okay, this is tangent formula here. Now the first thing I take note is the word how they phrase it, which is by taking the difference of two angles. So this difference of two angles here, and because they're using tangent, so very likely you need to be able to fish out what is the right angle triangle here, right? Because any trigo ratio you're doing here, you need the right angle triangle. So it's very typical that we actually need to look at this angle. So what are the right angle triangle involved here, which is here and here. These are the two right angle triangle here. So if you want to, then there's one telltale sign. The other telltale sign is the difference between the angle. So I'm going to let this as my A, and let this be my B. Okay, so that will be, let it be alpha and beta as well. It doesn't matter. So I'm going to just let AKD be A. Let angle AKD equals to A. Okay, maybe I don't use A because there's A, so I'm going to use alpha then. Alpha, then this is beta. Okay, great. So this is alpha. And angle AKC equals to beta. Okay, great. Now from here, I can express theta as a difference of two angles, alpha minus beta. Alright, that's pretty okay. Now, then what we're going to do is actually just find out what is the angle, the ratio of beta here, which is here. This case, we're just gonna examine this ratio here. So very simply, if you take this right angle triangle here, let me just put this out nicely. So this right angle triangle here. Okay. So from diagram. Okay, maybe I just put this over here. So hence this will imply this. So from diagram. Okay, we know that tangent beta is actually A, because this right angle triangle here, tangent is opposite over adjacent, which is A over X. Okay, then after which tangent alpha, we look at the triangle which involves alpha, which is this one here, right? This tangent alpha here. So alpha is this whole thing here. So we have 4 plus A, this is 4 plus A over X. So this will be 4 plus A over X, 4 plus A over X, right? Then what we're going to do is actually just use because we want to find tangent theta, right? So we're going to use the formula from MF26, the tangent a minus b, that formula there. So let me just bring MF26 out. So here, this is my MF26. Yeah, there you go. This is the one. I'm going to use this formula here because I have all the ratio of the trigo ratio, tangent ratio of a and b. So this case here will be hence tangent theta is equals to tangent alpha minus beta, and this will be tangent alpha minus tangent beta over 1. Put this as 1 plus tangent alpha tangent beta. Right? So that's how we do this here. Then what I'm going to do is just substitute all the ratio which I have. Right? So the tangent alpha is actually just 4 plus a over x and minus a over x here. This 1 plus 4 plus a over x times a over x. Okay, so this case here is 1. I think that's the beauty about having a show question, because then you know that you're right or you're wrong by just looking at this. So this case here, I'm gonna just make it a common ratio on top and bottom. So this is 4 plus a minus a over x. Then this over here will be x squared plus a plus 4 plus a over x squared. Okay, so this is just normal algebra which we already know how to manipulate, so I'm not going to just go through all the nitty-gritty here. 4a plus a squared, and what we get is actually just 4x. There you go. 4x squared over, so 4x over x squared plus 4a plus a squared. Shown. Alright. Shown. There you go. Yeah, that's how you do this question here proficiently. Let's look at the next part. So for the next part, we are told to find in terms of a the value of x which maximizes the tangent theta. Simplifying your answer. Find also corresponding value of tangent theta. You need not show that your answer gives a maximum. Okay, so it means we don't need to find that is maximum. Now, take note, we need to maximize. The phrase here is maximize tangent theta. Okay, so you see this as an entity. If you are not too sure, you can just let y equals to tangent theta. So what I would foresee that many students would do is actually they try and find the maximization of theta, but it's not. Okay, you need to maximize the tangent theta. So what you can do is you can let if you're afraid that you get confused here, you just let y equals to tangent theta. So this is y equals to 4x over this case here 4x over x squared plus 4a plus a squared. Now I am a strong proponent of using implicit differentiation. I don't really like to use quotient rule. I don't think generally yeah, so what I'll do is I'll just maybe just multiply this up so that this will be easier. So this is x squared plus 4a plus a squared. Okay, what I want is to maximize y, which is my tangent theta here is 4x. So then what I'm going to do is actually just differentiate with respect to x. Then from here, what we're going to get is y. Then this is y, u, and this is v, right? So the product rule, keep the one on the left, differentiate, so it's 2x, then plus x squared plus 4a plus a squared. Then we have dy dx here equals to 4. Okay, so there you go. So this is my answer here. So we don't need to show that is maximum. So at stationary value, at maximum or stationary value, okay, we know that dy dx is actually equals to 0. So what you get is actually this will be 0. We don't need to find the second derivative here. So this is 0 very conveniently. Everything is 0. So we get 2xy equals to 4. Okay, this is what we get. So find the value of a for which, find in terms of a, the value of x. Okay, so here we have y equals to, so y, we just replace y back in because now we want to find this, right? So it's 4x. We're going to replace that in. So it's 4x over x squared plus 4a plus a squared equals to 4. So that will be 8x squared equals to 4. X squared plus 4a plus a squared. just gonna simplify this. Gonna just solve this using quadratic expression. Just expand this. So this is minus 16a. Wow, okay, minus 4a squared. Okay, maybe this is a bit more. Okay, maybe just do it nicely. 16a squared, then this will be 4x squared goes to 16a. Actually, what am I doing? Oh goodness. I could just cancel this. 2x squared equals plus 4a plus a squared. X squared equals to 4a plus a squared. Then x would just be plus minus 4a plus a squared. Okay, but we need to reject 1, obviously. But a squared plus 4a, is it always positive? Doesn't necessarily. We can complete the square. A plus 2 square minus 4. Yeah. So it's not necessarily positive, but because a, we are given that a is, what is a? We need to find a. A is actually less than 4 because we are told that this is it 4? This is 4. Okay, we wouldn't know. Oh, then it will be, should be more than 4. This is 4. I think I'm thinking too much because a is always positive. So you just take the positive region. Okay, a is always positive since reject the negative because reject the negative because a is positive, right? Check negative for a square as a is positive. It could be 0 because it's on this side here. If you look at properly, this is a here, this side. Okay, I don't think it's important to write that down, but it's good to just understand it because sometimes the question will require it, right? So then after which we are going to find that is our x value which maximizes tangent theta. Find also a corresponding value of tangent theta. So hence tangent theta will just be just substitute this tangent theta in. This case here would just be 4. Tangent theta equals to 4 x, right? So this is 4a plus a square over 4a plus a square plus 4a plus a square. That will give us 4a that will be 4a plus a square plus 4a plus a square. Goodness, so many of these a's, and so this will be 2a square plus 16a 4a plus a square. Yeah, could simplify it. Just divide by 2. This will be 2a square plus 8a. Just factorize the 2 out. Okay, just make sure you are okay with this part here. So just factorize the 2 out, and you can just simplify this part here. So I wrote something wrongly. This is 8 actually. So this would just be 4. So let me just write this down, okay? I went to multiply it. So this is 2 divided, this is 4a. I think it's perfectly fine to leave your answer as such. If you want to rationalize, you could, because you can see that this is 4a and a square, you could actually just multiply top and bottom with this, but I don't think there's a need to do that because we weren't told to do that. So if you just do this a square and this is 4a, okay, I don't think you need to do that because this could be your answer, okay? So when you multiply top and bottom, you would get 2 4a plus a square over a square plus 4a over square root 4a plus a square. So you could just simplify this as this, okay? But I don't think you need to do that as usual. What I'm saying is you can leave it like this or like that. Just leave it as such. It's fine. So that's how you do this part here. So let's look at part 3. Now the corresponding value of x found in part 2 it's called the optimal point. The corresponding value of theta is called the optimal angle. So explain why a player may decide not to take the kick from the optimal point. Okay, now let's try and understand the question here. So the optimal point is when we optimize the angle, means when theta is tangent theta is max. Okay, maximum. Now, when tangent theta is maximum, it also means that theta is max. Alright? Because this is in the first quadrant. So anyway, why do we need theta to be maximum? Because if, say, you have a... Okay, now this angle here will give you the trajectory of the ball to go into the... to be scored within these two poles here. Right? So if you have a larger... larger theta, okay, it means that you have lesser room for error, so lower margin of error. So if a large theta, and then this is a small theta, we need to understand this first, okay? So the reason why we need to maximize theta is because you can just imagine if you have a larger theta, meaning to say you have lower room for error. So it only makes sense then, okay? So how do you actually think about it? So of course here you have a very small angle here as compared to here. This has a larger error. So this angle here is larger. This is smaller. So you wouldn't want to squeeze yourself to the end there. Okay, but the problem now is this. Now since you have lower room for margin of error, why a player may decide not to take the kick? Okay? So one thing I would suggest you to think about this game is you think about from relate it to a real life game. Okay, this game here is actually like rugby, American football. Once you score the scoreline here, you can actually kick into the two poles there. The problem with this calculation here is we are only considering the calculation based on this plane, meaning on this field here. So it means you never consider how high you want to kick, right? So you have to consider what is the rule for kicking into these two poles. Like it may be an optimal angle here, meaning this is maximum, but this angle of elevation is going to be immense as you get closer to the poles. Okay, it really depends on how high you need to kick as well. So one of the reasons why, which I think is a pretty solid reason, is we didn't consider the angle of elevation. Okay, so this is what I'm going to write. So basically, part 3. Our calculations of optimal angle and optimal value, right? Optimal point is based on the plane x on the xby. Okay. We did not consider the angle of elevation required for the ball to be kicked between two fixed poles. Okay, so for example, that is, if there is a minimum height to be attained, okay, the closer k is to xy, let me just write this down, closer, the larger the angle of elevation required, okay, to score. Hence causing the kick to be more difficult. Okay, this may thus the player may decide not to take the kick, okay, from the optimal point. So that's the reason. Okay, I think this is probably one of this is a solid reason where you because the calculation is only based on 2D. Generally, the idea is the calculation is based on 2D. what you need to consider is the 3D. Okay, the pole being erected from the field. So like how high he has to kick or how low he has to kick. It really depends. Okay, so this is one of the reasons why. So let's look at part 4. Show that when theta is the optimal angle, tangent KDA. So KDA is here. You're looking at this tangent here. Is the value there. So what I'll suggest is actually just write down what is KDA. So KDA opposite this angle here. KDA is this angle here. So we need its opposite, which is x, and the adjacent, which is 4 plus a, right? So I'm going to write this down. Okay, so this part 4. Tangent KDA is equals to opposite, which is x over, maybe I just write this down as x KA, AK over AD, which is actually AK, which is x over plus 4. So at optimal point, okay, we know that x is equals to, we just take the square root 4a plus a square, square root 4a plus a square. Then what we're going to do is actually tangent KDA would then be angle KDA. Right? Okay, so this would be 4 a square a plus 4. Okay, so we need to actually just there you go. This is a plus 4. This is a plus 4. So we need to essentially find the square root of this. So one of the neat trick that you could do is actually just square and just square root. Okay, so then this square root, we just use the formula where this is square root p over q is equals to, maybe, no, sorry, square root p over square root q is equal to square root p over q. Okay, so this is easier. So you just square root in and out of this. This would then be a plus 4 over a plus 4 square. Great. So once this is done, we'll get this as a plus 4. There you go. That is shown. Now this is a good thing because this question showing at the end, you can be very sure that your previous answers are all correct because they are all anchored based on the last the previous parts. Okay, so I think this is a pretty good question here. So find the approximate value of KDA when a is much greater. So when a is much greater than 4, okay, it just means that a tends to infinity. So when a tends to infinity, a over a plus 4 will just becomes 1. Am I right? So okay, maybe I should just multiply this with 1 over a here, 1 over a. This is or you can just do long division. So anyway, this would just be 1 over 1 plus 4 over a. So when a goes to infinity, 4 over a. We've done this many times in class, so just make sure you know where you're looking for this information here. So 4 over a goes to 0. So this case here will just be 1. Okay, so when as a goes to infinity, okay, maybe I just, this is 4 over a, tangent KDA. So let me just write this down. This is as a goes to infinity, tangent KDA goes to limit a over a plus 4. This can change this expression 1 over 1 plus 4a. We know that this will become 0. This will be 1. This will be 1. Okay, so hence tangent KDA tangent inverse 1, which is actually pi over 4. Okay, 45 degrees. So are we surprised that 45 degrees should be the optimal angle? I think not, because when you if you look at this graph here, the optimal angle, you should be able to find a 45 degrees as you move along this point here. Okay, your point as you adjust. So it will increase and then it will decrease after a while. Okay, so that is how you do that there. So let's look at part 5. It's given that the length of scoring line XY is actually 50 meters, so it's here. Okay, this is 50 meters. Then after which, find the range in which the optimal angle lies in, and the location of A varies between X and Y, X and C. Now this is 50 meters and we know that these are P and P. So we know that this is 4. We know that A can range from 0, but of course not equals to 0 because because this is A, right? Point A can vary from here to C. So let me just write that down because this is important. We need to form an inequality because we are asked to find the range which the optimal angle lies and the location of A varies, right? So from diagram, we know that A is 0 to XC. So since XY is 50, this would imply that XC is actually 50 minus 4 divided by 2, right? So just solve it geometrically. I think this is not like rocket science there, because this is 4, then this is 50. So 50 minus 4 divided by 2, that will be our range here. So this one, you key in calculator, I think it will give you 23, right? 50 minus 4 divided by 2, 23 meters. So we know that A is between 0 to 23, at most 23 meters, okay? Once you're done with that, once you're done already, we could actually use the optimal angle, because we find the range of optimal angle, right, which is this part here, tangent angle. So optimal angle is actually this, just divide by, so tangent inverse. So optimal angle, theta is just tangent inverse with 0, so that will be 2, you can use either one, so I'm going to use maybe this is easier, 2 over tangent, maybe I just write this down, tangent of the optimal angle, tangent theta is equals to 2 over square root 4a plus a square, 4a plus a square, 4a plus a square. Okay, let me check. Okay, this is it. So in other words, optimal angle, so theta is just tangent inverse 2 over 4a plus a square. Now I think it's better just use GC to just calculate the maximum, because you don't really know whether this is you can't really tell at the glance whether this is absolutely increasing or decreasing, like strictly increasing or decreasing. So it's not going to be good to just simply deduce the max and the min based on the boundary condition here. So it's good if you can just key in calculator and know that your A is between 0 to 23, and then you just find what is the max and the min point. That's about it. So I would suggest doing that. But know what you're looking for, because now it's an angle. So angle is between 0 to pi over 4. So if there's a window setting, it'll be good if you are able to understand that. Yeah, I'm just plot this angle out. So tangent inverse 2 over 4a. So this is 2. Very good. 2 over square root. Sorry. It's tangent inverse 2 over square root 4a plus a square. Square root 4x plus x square. Okay, there you go. So this case here, what we're gonna get is essentially 4a plus a square. Is that right? Okay, great. So then I'm going to go window. Now make sure you know what you're adjusting, because now x is your a, which is from 0 to 23. So I'm going to put this as 0 to 23. 23, maybe put to 25. Okay. Maybe you could also put a domain here. Okay, so just put this 0 to 23. So this is 23 here. So then once you're done, you can just key this in, y min, y max. I'm going to put this as 0 to pi. I think it's more than enough. Pi. Okay. Then we can get this graph here. So you can see that this is a decreasing function. It goes to this value here. And then you can actually see this is the function that you get. All right. Okay, what do we get at the end there? We will get, so this is a strictly decreasing function here. So the minimum point will be at this end here. So just trace, just put trace 23 at the maximum point there. This is 23. This is 0.0800856. Okay, so from GC, theta, the minimum point is 0.08008. 0.08008. Okay, so this is a strictly decreasing function here. Then at the maximum, can I equal to that? So this is equal to this portion 23. So this is equal to this. Then this 0. Okay, when it's 0, it's quite straightforward. 0, 0. This tends to infinity. Okay, it's actually, when this is 0, this is infinity. It's actually pi over 2. Okay, so you check. This is actually, as a goes to 0, 2 over 4a plus a squared goes to infinity. So hence, theta goes to, if it's infinity, it's pi over 2 definitely. So this is pi over 2 here. Okay. You can just check. I don't think you will get the answer at when it's 2. It will be undefined. Let's just trace 0. Yeah, you don't get the answer there. So anyway, you can just deduce from here. So that's how you do this question proficiently. If you have any questions at all, please let us know. Keep practicing, and I will see you in the next question then.